Hi everyone, welcome back to the channel. This is Rosario Borgesi and in this video we will see how to create a Rust smart contract, in particular an ERC-721. We will see how to compile it and how to deploy it on Arbitrum using Stylus. And we will also see how to interact with it using Viem. So let's get started. Let's start by introducing the Arbitrum chain, which is an L2 optimistic rollup of Ethereum, meaning that it aims at scaling the Ethereum layer 1. So it aims at basically increasing the throughput of the layer 1, so increasing the number of transactions per second, and also it aims at reducing the gas fee for each transaction. How does it do that? It is very simple. It assumes that each transaction is valid unless it has been submitted a fraud proof for a transaction. In fact, there is a window of time of about 1 week before the transaction are submitted from Arbitrum to the Ethereum layer 1 by means of a smart contract, and in this window of time it is possible to submit a proof of fraud of a transaction. But unless this happens, the transaction are implicit assumed as valid. So after this brief introduction, let's jump to the Medium article that I have created for this video. So we have already given an introduction on Arbitrum. Now let's talk about Stylus. Stylus basically allows the developers to write smart contract in language that are WASM compatible, like for example Rust, C or C++. And in fact it introduces as you can see here a virtual machine, a parallel virtual machine that allows to compile and deploy this smart contract written in this other language, while also maintaining the compatibility for the Solidity smart contract, which are of course compatible for the Viem. So this is the basic difference between a typical Viem which only supports the smart contract in Solidity, which are then compiled in Viem bytecode, and then there is the Arbitrum Viem, which is that processes this smart contract, while in the case of the multi-virtual machine, you have that you can write the smart contract either in Solidity, so you provide an Viem bytecode that goes on Arbitrum, but also you can write the smart contract in Rust or C or C++ that go into this WASM virtual machine and also are executed. So this means that when we deploy a smart contract in Rust to Arbitrum, we are able to use the same tools that we are used to with the Viem smart contracts to interact with them, such as Viem, for example, a library as Viem, as we will see in this video, and to write smart contracts that are WASM compatible, so that allow us to write smart contract in Rust, we will use Stylus, which is an SDK provided by Arbitrum that allow us to compile and also to deploy the smart contracts in Rust to Arbitrum. So the first thing to do is to install cargo stylus. So here are the commands that you should execute. I already executed them. Here I've provided the link to the official documentation of Arbitrum, so it is explained there pretty well. Then let's start by creating a new project with cargo stylus. Start by opening a terminal. If you are in Windows like me, use WSL2 and just type cargo stylus new. Let's call it stylus demo, and this will create um, a new stylus project. So if we open this this repository here with VS Code, this should be Stylus demo, the repository. So as you can see here, there are a bunch of files, but the file that contains that will contain our smart contract is this file here, lib.rs, which here contains a basic counter. Okay, and then there are of course the cargo lock and cargo tom. These are of course the configuration file. Let's create our new smart contract. In our case, we want a smart contract that allow us to mint new NFTs, but at the same time allow us to set for each new minted NFT the token URI, which allow us to store the metadata of the related to the NFT, which can be stored, for example, on IPFS or on whatever type of server. But in order to do that, we can create a new variable called basically a storage, a map. Here you can see the key are U256, while the value are strings. So basically we are creating a simple string that maps each ID with the token URI, which is a string, and then we implement two functions which are set token URI, which is a setter for this variable here, and also a method function token URI, which is a getter to retrieve the value the URI associated to each token ID. There are a couple examples that I have used to create this smart contract that I have reported here, but this is basically the smart contract that it has been created. As you can see here, I have imported this library unchecked .rs here that it is used until here, that is used here in the smart contract created by OpenZeppelin that I suggest you to take a look. I basically taken some parts from this code and adapted it for our use case. Then of course here there is the definition of the ERC-721. As you can see here are defined the events, also the error, and also here the methods. This is this could be a starting point just to give you an example on how to create an ERC-721, but maybe all these methods which are public, not all them it is required to give them public visibility, but we could also make some of these functions private for security reason, but this is only a demonstration, so I have leave them all public. And so this is a basic, very basic ERC-721 that we have discussed also in other video. If you are new to the ERC-721, I suggest you to check out my channel, where you can find a lot of useful video. For example, the first one, it is this that explains how to create the NFTs, basic NFTs on Solidity. So it also explains what are the ERC-721 and so on. And also another video that could be useful for the when we will interact with the smart contract will be this one, the Viem tutorial, which allows which I suggest you to check out if you are new to Viem. But coming back to our smart contract, the first thing to do is to check out if our smart contract is valid. So we could just copy all of this, copy all of this, okay, and in our repository, maybe it is better if this if I change directory, I open it inside the directory that I have created. So okay, perfect. So now in this SRC library, we can replace the older code, the counter, with this new smart contract. Another thing that maybe I haven't said earlier is that I created this new mint token function to mint our new token. Function mint token, as you can see here has a counter which gets increased once we call this function, and also it receives an input as a parameter the token URI that then we use to pass it to the setter of the token URIs. This is the map that we were discussing before. So this is the first the third method that we have added to our smart contract that was not present in the original implementation provided by OpenZeppelin. So once we have copied this this smart contract here, the thing that we must do is that we should run, for example, here cargo stylus check -c. This is the RPC URL that I use for the Sepolia testnet. Of course, if you like, you can also test it in the mainnet with this other command. So let's run it. Okay. Okay, now it is compiling our smart contract, and if it is correct, it should say that everything went well. Let's wait just a little bit. Okay, it has compiled. Here there are some warnings. Okay, no problem. Here the smart contract has been compiled. Basically, it is verified that can be deployed. So now what we want to do, we want, for example, we could also try to estimate the gas fee for deployment. So I forgot to tell you that since we have to pay the gas fee, of course, you need to have a MetaMask wallet or Coinbase or whatever, and also you need to found this wallet with some test ether. You can use whatever faucet you like. There will be always, of course, some faucet for Arbitrum, but you can also, for example, found with the test ether the your wallet on Sepolia and then use a bridge to Arbitrum Sepolia to move to bridge your funds to your to the Arbitrum testnet. If you don't know how to do it, I suggest you to check out my video on MetaMask. But let's do this. Let's clear the console. Let's run this command. Of course, here um, don't ever share your private key with anyone. Okay, so let's try this command here, estimate gas. Here it uses Docker. You have to have Docker installed because it runs this container to do this check. Should not take too much. Okay, here there are the classical warnings. Here, okay, it has estimated the total cost for this transaction would be this amount of Ether here. So now let's try to deploy our smart contract. Let's do it with this command, cargo stylus deploy. So we are going to deploy on the Arbitrum testnet. Okay, so our smart contract has been deployed at this address. Okay, I copy this two lines here so we can use them in our code. This is the address of our smart contract and this is the transaction hash. So we can check here on, for example, if we go to Arbitrum Sepolia, we can put this transaction hash. Okay, we can see that this is the smart contract that has been created, F39. So this is this one. Okay, from this is my address, of course. And so 50 seconds ago, this is the confirmation that our smart contract has been created. We can check here the smart contract. Of course, we could also verify the smart contract, but we will not do this in this video. You can check out on the Arbitrum documentation that it is provided on the video. This is the documentation that you can check out if you want to learn more. You will find it in the description. So our smart contract has been correctly deployed. Coming back to our article, we could, for example, also exporting the Solidity ABI interface. This will be useful, will be needed later on when we will use we will create our VM project to interact with our smart contract. So we can do that by running this. So let's clear the console and run this code here. You should print the result to the console. So once it has finished, it prints the here as you can see there is the ABI. Okay, so we can copy it or we can write it directly to a file. I have reported it here in the article here. So the next thing to do is to create a new VM project. Sorry, a new Node.js project with TypeScript and PNPM that you can find in this guide here that I have provided. It is very, very simple to do. So you need to maybe modify the tsconfig and also the package.json if you haven't done it before. But of course you need to install Viem. Which has not been done, of course, in this guide because this is general. And so let's do it ourselves also in this video. So let's go to our here to our repository. Let's do something like npm init. No, sorry. First, I need to create a new repository. Let's call it make dir vm Arbitrum. Okay. So let's change directory to VM Arbitrum. No. So make clear VM Arbitrum. VM. Okay. So now we can start a new project. npm init. Okay, fine. Now, of course, we need to install all the dependencies. Okay, it has installed them. Let's create a new tsconfig file. So touch tsconfig.json. Okay, let's open this in VS Code so we can modify it. Let's close the old repository. So in this tsconfig we copy the code that I've reported in the guide. Then we can do make dir create the src directory and also touch src dot slash index.ts. Okay, I could have done it also from Visual Studio Code, but it is not a problem. Okay, let's for now let's just print hello world. Then let's configure the here the package.json. We need to add main, which is src slash index.ts. Then we need to write type module. Okay. Then we need to add this script here, dev, so we can execute the npm run dev. And then I believe that we have everything. Okay. Once we have done this, I believe there is everything. Let's try to run this project npm run dev. Okay, hello world, fine. So now coming back to our project, we need to create in the root a new file .env where we put the private key of our wallet and also the RPC URL of our wallet. I will post the video. Of course, you put your own here. Okay. Once this has been done, we can just the first thing to do is to deploy our to mint the transaction. So here there is the whole file that I have created that we now can discuss. We put this here. Okay. So now, as you can see here there is the address of the deployed smart contract, which is this is old. Let's put this new one. The wallet of my address, it is always the same. Here we are creating a new account we are reading our private key and creating a new account. Here we create the wallet client because we are using the account that we have created, plus we are using the chain Arbitrum Sepolia, and we are specifying the transport that will be on our RPC Maybe it was not necessary to write this if you are using the default RPC but if you have a custom RPC you can put it here. So let's just try to run this code here to see if the gets the right address. So it means that it is reading correctly the private key and also the other environment variable. So let's run npm run dev. Okay. So as you can see, the wallet address, it is correct. So let's try now to mint the first NFT. So here, as you can see, this is the we are we are generating the ABI using this parse ABI function that is provided by Viem. This is copied from the API that we had extracted before with cargo. Okay, so we need to let's comment out this code for this for a while. We need to call the write contract function, and here we are calling the function mint token. Okay, we are passing the address of the smart contract that we have deployed before. The ABI, it is this one, of course. Only the method we are only taking the method that we are going to call. If you want, you can use the whole ABI, but for the purpose of this video, only these four methods are of interest. And so here we are specifying the function that we are calling, which is mint, the function mint token that we have discussed earlier, and the arguments, these are the arguments of the mint token function, which are the address of the receiver and the token URI. that the token will assume. So we are passing a basic string. Of course, here you can put your IPFS URL or whatever you want. The chain is Arbitrum Sepolia, and we are using the account that we have defined earlier. And here we are logging the transaction receipt. So let's run this code. Just run pm run dev. Okay, this is the receipt of the transaction. It can be checked on, of course, on Arbitrum Sepolia. As you can see here, we have minted the token ID number 1, okay, and it is minted to my address, which is this one. So it seems that this is the address of the smart contract. It seems that everything went fine. So now, if you want to test this further, we can call, for example, and see if the smart contract works. Here, we can uncomment this and comment the right contract method because we don't want to mint more NFTs. So we are saying here, here we are calling the total supply method. So we expect to see one token minted. So the total supply which should be equal to 1, and here we are calling the token URI method on the token ID number 1. So we expect to see this string here. Okay. And then of course, last but not least, we are calling the owner of method also on the token ID number 1, which should be my address, okay, that ends with the 368, this one. So let's run this. Let's clear the console and run this code. Okay. The total supply is 1. The token URI of the token number 1 is URI of the token 1, and the owner of the token 1, it is my address. So guys, we have reached the end of the video. If you have any questions, please drop a comment below, and I will reply as soon as I can. Thank you for watching this video, and see you on the next one.